We will do some problems. Okay. So yesterday we were doing variable source. Okay. Variable input and variable load. Okay. We are doing this case. So let us do. Board is clear, huh?
Sir.
This case is done. Worst condition, na?
Yes. Problems are remaining. Problems.
Yes, problems.
Okay. So you have been given a variable varying from 15 to 20. Okay. And you have been given a load. Okay. And you have been given this one. Okay. And the voltage is 6.8 volt. And IL, they say IL, they have given the limit. Okay. It can be maximum. It can be go from minimum to maximum. The limit they have given. Okay. And now this thing, what should be the value of RS maximum? Okay. What should be the RS? They asked what should be the RS. Okay. The two things, one is RS can be what is RS minimum and what is the RS max. Okay. And they asked what should be the RS max. Okay. Out of given options, and option they given 390. Here options are important. Okay. 420 ohm, C 440 ohm, and D 460 ohm. So now I want to calculate RS max. Okay. And you know RS max can be calculated for V minimum. Okay. So the RS max is V minimum minus VZ upon I. Okay. I, and that I this time can be written. Okay. I can be written as a V minimum minus VZ. Okay. IZ minimum, because this is a minimum, so this will be also minimum. Okay, if this is fixed, and this can be written as the IL max. So they should be they are asking like, what is the exact value of RS. They should be after given option what should be the RS. Okay, so now I am calculating the upper limit. Upper limit means in the question IL max is given, but IZ minimum is not given. Okay, so IZ max means how can be IZ max? Okay, so suppose all the current coming here go here, that will in that case that will be your IL max. Okay, and in that case IZ will be 0. Since IZ is not given, okay, just for calculations I am assuming that my IZ minimum is 0. So this is
Sir,
my
यहाँ load resistor नहीं है.
लोड रेजिस्टेंस करंट दे रखा है, लोड रेजिस्टेंस नहीं, करंट दे रखा है, सीधे करंट दे रखा है. ओके, अगर लोड रेजिस्टेंस दे रखा होता तो then also you can calculate IL na, because voltage is fixed, RL value given minimum maximum, so you find it.
I have to assume there is a
And you can also calculate you can also calculate RL minimum, RL maximum if the variable load is given. Voltage is fixed, so you can calculate the current limit also. So this has become now 16 minus 6.8, and IZ not given, so I'm taking it to 0, and I am taking IL max 20 milliampere. Okay, tell me.
Sir, can you please can you please tell me why you have taken the mean value 16? The internet connection got interrupted.
R max is always calculated for V minimum, no? If I am applying V minimum, and if my RS is greater than RS max, then automatically this will come out of conduction. Okay, are you getting my point? If this is 15 minimum, and if this go higher than some particular value, then this current will become 0, or you can say that diode will not conduct. Okay, similarly if this current is voltage is high and this resistance go less than value, okay, this goes less than some critical value, then this current will increase, okay, and then that can burn the your general diode. So that is a limit. This are limits, okay. So V minimum, you should know your value should be not very high, not okay. And obviously when this is 20 volts, that will be that will be greater than this RS max. But if lower voltage is there, okay, then there is an upper limit on this one. Similarly, if there higher voltage is there in the circuit, then there is a lower limit of this one. Okay, you cannot make below this one. If you make below this one, current will increase and IZ will increase, and that will burn the sample, assuming diode is conducting. Okay. So here I am just calculating what is the value here. Tell me.
Sir,
Hmm.
we have used yesterday's formula.
Yes.
My doubt is why we have taken IL max. Yes, ये समझ में नहीं आता. IZ minimum बाकी सारा formula समझ में आया. IL max.
तो obviously करंट जो होगी वो IZ मिनिमम होगी, तो ये मैक्सिमम में होगा ना हमेशा ही. करंट I तो फिक्स होता है. अगर यहाँ मिनिमम हो गया, this I is equal to this one and this one. If this is minimum, so whatever going here, that is a maximum. Okay, whether you call fixed current or whatever, that is current is maximum. If this is minimum, automatically this is maximum. Okay, I are related by IZ minimum plus IL max. Okay, so in the question that you have, they have given upper limit, they have given. Okay, so for upper limit, you are assuming that your IZ is 0. And why assuming, I will tell. Okay, now it's not recording. It's recording. Okay, now what is the value? Tell me.
Sir,
Huh?
hello, sir.
Tell me.
Here IZ minimum is 0. How, sir?
Just I'm telling them, I'm going to explain you. Okay, you wait. Okay, so now tell me what is the value of this one.
सर VL मिनिमम तो 15 रखना चाहिए ना अपन को.
15 कहाँ से आ जाएगा?
15 से 20 दिया ना अपन को.
15 कहाँ दिया है?
वेरिएबल देखो, 15 से 20.
तो ये 15 है आपका ना? ओके,
हाँ
15. अब बताओ कितना आएगा?
इस हिसाब से सर 410 ओम आ रहा
है सर. 410
ohm. Very good. 401 coming. Okay, now this is the upper limit. Anything greater than this one will not work. Yes or no?
Okay, so option A will be correct.
So option A will be correct, but this is not a value of Rmax, because here you taken IZ minimum 0. If this is slightly greater than, then the value will be less than this one. Yes or no?
Yes sir.
That's why I took 0. So now this is upper to upper limit. Okay, so any value which is less than this one, okay, I don't know what is the IZ minimum here, but in the question they didn't ask exit value. They were asking what can be the RS max out of these options. So RS max, obviously these 4 options cannot be there. Okay, so only this option is correct. This option is less than, so this option is there. Okay, so all the questions where you don't know IZ, what is the IZ minimum? Okay, in that case you can take 0. Okay, so in fact the formula for this RS max is, okay, the formula for this RS max is, this is IL max. Okay, you remember this formula. Either always you can take 0. If it is given the question, if it is given, then you can use RS max equals to V minimum minus VZ. Okay, IZ minimum plus IL max. Okay. Yes, any question? Who was asking why should 0? Bulela, is that clear now?
Sir, my network connection is too low, so that's why I'm asking.
So I'm explaining na. If I have calculated now the 410, I'm assuming IZ minimum 0. Okay, because IZ minimum is not given in the question.
Yes, sir.
Now, if it is given question, so obviously this factor will increase. Yes or no?
Yes, sir.
And then this value is decrease.
Yes, sir.
Then which is the less value? Less than this one.
390.
390. That's why.
Thank you, sir.
Okay. So I'm giving you one more problem. Okay, these all problems came in exams. Okay, so in this way, they only give, they given the answers. Okay. So there's one more problem. (22 to 30 volt). Okay. Now this is RS and this is your 12 volt. Okay. And now this time they have given a resistance. Okay. That is 140 ohm to 10 kilo. Okay. Now they're asking what is the RS max. Okay. So RS max formula, V that IZ minimum is not given. That will be simply V minimum minus VZ upon IL max, because IZ minimum is not given. Okay. And V minimum minus VZ, IL max can be written how much? IL max will be what? VZ upon RL minimum. Yes or no?
Yes, sir.
This is V minimum minus VZ upon VZ into RL minimum. Okay. So if you want IL max, the max will be here, voltage is fixed. So current will be max only when the resistance is minimum. Okay. So the formula for IL max is VZ upon RL minimum. Okay. And this will be 22 minus 12. Okay, 12 into RL minimum is 140 ohm. कितना आ रहा बताओ? How much is coming? So this
So
comes,
0.33 into 10 raised to 4.
ये कौन सा आएगा? ये 22 minus 12 ना? 22 minus 12 कितना होता है?
116.67.
Just
116.67.
167. This is the value. Okay, the value should be less than this one in the circuit. The upper limit. Now let me calculate. Now the next application is diode clipper circuits. Okay. Diode clipper circuits. Okay. So clipper, what is the purpose of clipper? Okay. Clipper circuits. Okay. Clip or remove some portion of signal. Okay. Some portion of signal they remove. Now for example, the clipper circuits example is what? Can you give me the example of clipper circuit which clip one portion?
Diode.
Rectifier circuit and diode. Basically, we are saying diode clipper circuit application diode. So if I apply a signal, say Vs, okay, and I am putting a diode here, and if I try to take V load here, okay, or V output here, the resistance is R, and if I am applying here, say a signal, say V, this is my V input or Vs. So V output will be what? Tell me, what will the V output? For positive cycle, okay, this will be short circuit, and the negative cycle, this will be open circuit. Okay, so no signal will you get at the output for negative cycle.
Negative half cycle.
negative cycle. Okay, so this is the example of clipper. So rectifier are the example of clipper. Okay, so here you don't get any signal here for this
Sir,
one.
can you repeat? My network was gone, sir. Just last statement.
Which last statement?
So this graph what you are telling.
So this is rectifier circuit. I already explained you. We have already done so many questions on rectifier. If it is a positive cycle, this diode is short on. That means it can
Yes,
be
sir.
short circuit. So all the voltage will come here. Whatever voltage
Yes,
you're
sir.
applying, here zero drop. Okay, so your input is zero drop here. All the voltage coming here. Okay, this is coming here. Similarly, negative
Oh,
cycle
yes, yes, sir. For it will be open, so it will not
open,
be
so
the-
no current flow. So this will be
Okay.
zero. Okay. Now suppose instead of applying this signal, I am applying some variable Vs. Okay, some Vs, some Vs. It's not sine wave. Suppose I'm applying only some value of Vs. Say Vs is positive. Okay, and Vs is negative. Okay, and this is your V output. So this is called your transfer function. Transfer function. Okay. Now, first case I'm taken this is a sine wave. Okay, now suppose it is not a sine wave. I can just linearly I can increase Vs. Okay, some value of Vs. So in this circuit, whatever Vs I apply, same V0 I get when Vs is positive. Okay, so when here if your Vs is positive, so you get same graph. V output is also same. Okay, and when Vs is negative, then what is the value of V0? Tell me. What is the value of V0? Zero. Zero. Okay. So this is the transfer function for this circuit. Okay. So any positive value apply, you get same output. Okay. Any positive value apply, you get same output. And negative value, you don't have V output. V output is zero, and negative value, your V output is zero. Okay. So this is another representation of this graph. So this is called transfer function. Okay. Now I will draw some transfer function, and same graph I will draw for another signals. Okay, so now what I'm doing, this same question I am little bit modifying. I am putting diode here. I am putting this diode here and RS here, the resistance here. Okay, now tell me what will happen when Vs is positive. If Vs is positive, linearly increasing, okay, then what will be the value of V output? Or बताइए. If it is the ideal diode, it's the ideal diode. Okay, and I'm taking V0 here. So positive input voltage, what will the output? Shivesh,
VS only, sir.
Vs only. So what you're learning for so many classes, huh?
0 volt.
You're doing, seeing again and again and telling that you use. If this is a
So-
diode, what will happen? Bulela, what will the output for positive inputs? How much is the drop across diode?
Oh, zero, sir, because
Zero,
it will
sir.
be
Ideal
short, no,
diode.
sir.
Ideal.
Zero, sir.
So ideal
Yes,
is
sir.
zero, na? If it is forward
Yes,
bias,
sir. Zero, zero.
zero. So any
Forward bias. Yes.
you have any apply Vs, you always get zero. And negative, what will happen? If you apply negative voltage, okay.
Then VS.
Okay, if you apply like this minus plus, then what will happen?
Then it will be open, sir.
Then V0 will be
VS.
Vs or minus Vs?
Minus Vs.
Minus Vs.
Minus VS.
Because you are measuring like this, and this voltage is coming like this. So your V0 is equals to minus Vs. Okay. So negative, it will be open. So no current is flowing here. I0. So no drop here. Whatever coming here, you come here. So this is plus, this is minus. This coming here. Now you're measuring like this. So V0 will be minus Vs. This is the graph. Okay. And if I see same thing here, so what will happen now? The output will change. For positive cycle, you get zero. Okay. And what will happen? Negative, sir. Now I should put positive or I put negative? What should I do?
Should be down.
Down or up?
Should be up, sir.
Huh?
Up. It should be up.
परमपित क्या होगा?
Down, sir.
डाउन ही होगा भाई, ये माइनस है तो ये भी माइनस, डाउन ही होगा.
Yes.
तो ऑलरेडी V आउटपुट लिया हमने ना, V आउटपुट शुड बी नेगेटिव. ओके, तो V आउटपुट नेगेटिव का ये तो पॉजिटिव हो जाएगा ना. V आउटपुट शुड बी नेगेटिव. Okay, so your V output will be 0 when Vs is greater than 0. Your V naught will be minus Vs when Vs is less than 0. Okay, so minus V output क्या आना चाहिए? माइनस आना चाहिए. तो माइनस तो यही तो है. You can understand circuits. अब इतनी क्लासेस हो गई, इतने क्वेश्चन हो गए. So let me draw some more circuits.
सर V0 हम प्लस Vs लिखेंगे ना लिखते टाइम.
क्यों लिखेंगे हम लोग? yes. जो आएगा वही लिखेंगे, जो आएगा वही लिखेंगे, और जो लिखेंगे उसी को ड्रॉ करेंगे. ठीक है. अभी तो Vs तो कितना आया? माइनस Vs तो आया, और जो ड्रॉ करेंगे तो भी V0 को माइनस Vs ड्रॉ करेंगे. Now you have been given a silicon diode. Okay, this is 0, this is V input. Okay, and silicon diode, you have the voltage drop. How much? 0.7. Now this is your plus and this is your minus. Okay, tell me the transfer function. I'm increasing V0. Okay, and this is your Vs, V input. Okay, so and this is R. So how will be the graph? Tell me.
To 0.7 volt, it will be an off.
Okay,
After that, it starts conducting, so it becomes 0.
very good. So if so, Bulella, how should I draw? Tell me.
Sir,
How should I draw? So I'm increasing Vs. What Vi? What
right side,
will happen?
right side graph, sir.
What will happen? If Vi is suppose Vi is 0.5, I'm increasing Vi 0. If it is Vi is 0.5, then what will be the output?
Oh, yes.
What will the output?
Negative, sir.
Negative. If this is 0.5 volt, okay, then what will be the output here?
0.5.
Tell me. So how much voltage this diode required to conduct? How much voltage this diode requires for conduction?
0.7.
0.7.
0.7. तो जब तक 0.7 नहीं, इसके ऊपर 0.7 नहीं आएगा, तब तक ये ओपन है कि क्लोज है?
Open.
sir.
और जब भी ओपन होता है, तो जो यहाँ होता है वही आता है इधर. ये करंट होता ही नहीं. ओपन है. ओके, सो ओपन है तो क्या मतलब क्या? 0.7 तक तो जो जितना लगाओगे 0.7 तक उतना ही आएगा. ओके, so you apply up to 0.7. Up to 0.7, this circuit is open. Okay, so when your V input is less than 0.7, okay, then your V out is equals to V input, because circuit is open. Okay, circuit is open. Now once you increase Vi, okay, greater than 0.7, then what will happen?
Voltage 0 हो जाएगा.
वोल्टेज 0 हो जाएगा कि कितना हो जाएगा? अगर ये कंडक्ट करेगा तो इसका
0.7 हो जाएगा.
0.7 हो जाएगा. If this diode conducts, then this will be replaced by a battery. और यहाँ पे वोल्टेज क्या हो जाएगा? फिक्स हो जाएगा. ओके, circuit closed and diode replaced by battery. Okay, so that will be your voltage will be constant like this after 0.7, and it will be constant at 0.7. Okay. Now negative में क्या होगा बताओ? Negative में क्या होगा? Negative में क्या होगा?
Open, same.
Negative.
Negative
If it is a negative cycle, this is always open. Bulela, if it is a negative cycle,
Yes, sir.
okay, so what will the output? Output will be plus Vs or minus Vs. If this is a negative cycle, if it is reverse bias, so reverse bias it will be open. Okay, so what is the voltage you will get here?
Plus जो आ रही है negative ही ले लेंगे.
Same thing, same you get like this. Okay.
Minus Vi.
Okay, if V input is less than 0, then your V output will be same like V input. Okay, now same you can draw for a sine wave. Okay, now suppose instead of this one linear, if I apply a sine wave of say 5 volt, okay, this is 5 volts and this is also 5 volts. Okay, so output कैसा आएगा? शुरू में तो बढ़ेगा ऐसा कैसा ही up to 0.7 पे क्या आ जाएगा? फिक्स हो जाएगा. Voltage will increase. Scale is not linear. Okay, so this will be constant at 0.7. And so if this is a volt, suppose this is a voltage 0.7. Okay, let me draw a little bit bigger. Okay, so you can understand. So suppose this is my input. Okay, and now this time I'm taking value little bit lesser, so scale should look good. Okay, and this is minus 2 volt, and say this is my 0.7 volt. This is 0.7 volt. Okay, so here, so below this one, this graph is your V input is less than 0.7. Okay, and now let me plot the V output. So V output will be, so whenever your V input is less than 0.7, then you get same Vs. Okay, so you get same up to here, up to 0.7, and when it is above 0.7, then your output becomes fixed 0.7. Okay, up to what time? Up to this time. Up to this time, you always get from here to here, from this point to this point. Okay, sine wave, then fixed, and if it is getting reduced, okay, less than 0.7, again the circuit is open, and you get at this graph again you get like a sine wave. Okay, and negative, for negative circuit is always open, so you get same graph like this one. Okay, so this is your clipper. So this portion will be clip. Clear?
सर
हाँ
इसके लिए रिवर्स बायस में हम जो वोल्टेज लिखेंगे वी नॉट,
हाँ,
वो क्या आएगा? वी आई आएगा या फिर उसमें कंफ्यूजन है?
क्या मतलब क्या आएगा? मतलब V आउटपुट इक्वल टू माइनस Vs है. ओके, इफ यू आर, अभी लिखा था मैंने यहाँ पे सब कुछ, इस जो इस ग्राफ के लिए वही इसी ग्राफ के लिए ही है. ओके, V नॉट विल बी माइनस Vm साइन ओमेगा टी, और साइन ओमेगा टी लिखो क्योंकि इस पीरियड में, फिर वो पीरियड के लिखना है तो बात अलग है, और आप पीरियड में लिख रहे हो तो फिर साइन माइनस प्लस साइन का आपको देखना पड़ेगा किस फंक्शन से
सर हाँ वही.
तो अभी पीरियड के लिखने की जरूरत क्या है? ठीक है ना, आप तो ये बोल रहे हैं कि पॉजिटिव या नेगेटिव पार्ट है, जैसे पॉजिटिव साइकिल नेगेटिव साइकिल बोल रहे हो. ओके,
सर अगर पीरियड के लिए लिखना होगा तो नेगेटिव में आएगा,
तो भी साइन ही होगा, पॉजिटिव साइन ही होगा,
हाँ
पॉजिटिव साइन ही होगा.
थैंक यू.
Now let me say one more question is there. Say this is diode. Okay, this is silicon diode. Okay, this is R, and this is your again silicon diode, okay, and this is your plus, this is minus, okay, and here I am applying V input, okay, which can be any function, okay, either linearly increasing or sine wave, anything, it can be anything, okay. So now you need to tell me what will be the transfer function for this graph, okay. तो थोड़ा छोटा बनाना चाहिए था जगह, I need the space, okay. So now tell me,
Diode भी silicon ही है sir.
silicon, both are silicon, okay. Now tell me what will the function, what will the output? So what should be the output? Both require, this requires 0.7, okay, this is also 0.7 for forward bias, okay. So अगर मैं पहले forward bias कर रहा हूँ, if I am applying forward bias, okay, बोलेला, if I am applying forward bias, which diode can conduct? Tell me, first or second? Which diode can conduct for positive cycle?
First one, sir.
First one can conduct. And what is the voltage it is required for conduction?
0.7.
0.7. And this is for positive cycle. This is always open. Okay. So this is always open for positive cycle. This is always open. Okay. So this is always open. And for negative and positive cycle for less than 0.7, this is also open. Okay. So both are open when the voltage is less than 0.7. So you get what? Like this graph. Up to 0.7, 0.7. Okay. And once the V input increases greater than 0.7, this diode becomes battery of 0.7. This is always open. So you get what voltage is here, the same voltage here. V output is this voltage. So you got same thing here. Okay. Now negative, what will happen? Negative cycle. If your input is negative, then what will happen? Tell me. If this is a negative
Yes,
now, tell me what will happen.
diode 1 is open, sir.
Diode 1 is open, very good. And diode 2 is
2 is conductor.
after what? When this is up to
And-
0.7. Okay. After that, this will become like this. Okay. So when this voltage, now what I'm changing here, when this voltage reaches 0.7, greater than 0.7, then this become diode. Okay. And now this is 0.7. Okay. This is minus 0.7. Okay. I'm measuring like this. So this will be always minus 0.7. V output will be negative. This is the graph. Okay. Similarly, you can draw now for sine wave. Okay. If this is the wave, say 2 volts, say this is your 0.7 scale. Okay. So you get output again. This will be, it will increase for up to here. Up to here, it will increase, then it will become constant. And up to here, up to this one, again, it will decrease. Okay. At this point should be, you plot carefully. Okay. You should give some slope here so that this distance go higher. Okay. And so this point you have 0, and this point again to touch 0. So same happens in negative cycle. Okay. When negative cycle you have 0.7 to here 0.7, this thing, then you get like this graph and like this graph. 0 for 0, and before you get 0.7 here. Up to 0.7, you get above 0.7, you get 0.7, and remaining it is open. Okay, are you getting what I'm doing? समझ में आ रहा क्या कर रहा हूं मैं? Same like here. Up to
Sir?
0. हाँ.
The question we solved before 4, in that the negative part was as it is, then why it is different here? I'm
Here
getting
also,
confused.
here also same, na? If this is less than 0.7, it is open, you're getting same thing. If V input is increasing, your V output also increasing. Linear curve. Here this is sine wave, here also sine wave. If it is goes above 0.7, this become fixed. If you go Vs here above 0.7, this become fixed. Same happening like this. Same is happening. Na?
Sir, in the negative cycle, it becomes open, no? So negative output will be as it is, no?
So there are two diodes. Na? This will be open now. For negative cycle, this will be open, but this will be conducting, na? This side.
Okay, okay, got it, sir. Got it.
Okay.
सर
हाँ
जो लास्ट पोर्शन है ना ग्राफ का हमने ड्रॉ किया है
हाँ
सबसे लास्ट वाला
हाँ
उसमें वो बीच में 0.7 उसके बाद वो
अरे,
ड्रॉप होके
वो ड्रॉप तुम देख लो ना यहाँ से जब भी 0.7 से नीचे है तब वो ओपन है तो वैसा आएगा जैसे ही
हाँ।
ये स्केल 0.7 से ऊपर जाएगा तुमको तो फिक्स हो जाएगा ये और फिर जैसे कम कम होगा ओके तो वापस साइन में आ जाएगा ओपन हो जाएगा
वही कम होगा वो
अरे वो बात तो एक ही जो जैसे यहाँ पर है वो सेम चीज तो यहाँ पर है अब इसको रिवर्स में मान लो ना यहाँ पर 0.7 पहुंचेगा तब तक ओपन है तो एज इट इज आ रहा है इसके ऊपर होते ही when this is above once this is above then you get constant value similarly in this negative cycle also when up to when it is below 0.7 you get same thing and above 0.7 you get constant value अभी इधर क्लियर
Yes, sir.
okay so that's why I'm plotting this transfer function okay now transfer function once you know the transfer function now they can give you any signal just seeing the transfer function you can immediately you can very fast draw for any signal whether it's a triangular wave whether it's a sine wave a square wave okay so first you draw always try to draw this transfer function then remaining things just you have to copy what is there in transfer function same thing you have to put in the signals okay so now let me give you one more question okay let us see who does this so I'm giving you V input here okay this is R and this is here ampere plus minus 2 volt 1 volt okay now tell me what is the transfer function for this one
diodes are silicon
diodes are silicons 0.7 0.7 0.7 okay now first of all you need to tell which diode can conduct when for which cycle okay that you need to tell me which diode can conduct and in which cycle
So for positive second one will conduct.
Hmm?
The positive second one will.
positive cycle second can conduct
Second.
but when
Yes, sir.
when it can conduct
above 0.7
Above 0.7.
above 0.7 just look at this one it is 2 volt also making this reverse bias now
yes more than 2 volt
so this is a diode it requires 0.7 here and there is a one more battery which is making negative here so until these two are giving
2.7 के बाद conduct कर
yeah so now the voltage should be reverse or reverse of this one at least 2.7 okay so after 2.7 this diode will conduct and the voltage will become up to fixed 2.7 and positive cycle this is open or forward bias or reverse bias this diode
Reverse.
Reverse bias.
This branch is always open. Okay, so for positive cycle, okay, so when Vi, so I will tell this is the branch first, I will tell the branch second. Okay, so Vi positive, okay, first branch is open, okay, Vi positive, second branch closes when V input is greater than equal to 2.7 volt. Okay, if V input is less than 2.7 volt, second branch is also open. Second branch is also open. Okay, you can write and understand later if you're not understanding now. Okay, now if it is all, if it below 2.7, if all are open, so you get whatever you apply, you get that one. Okay, same thing you get here. This is up to 2.7. This is also 2.7. Okay, after that it will fix up to 2.7. Okay, similarly thing in reverse, what will happen? Now if I applying negative voltage, okay, this is plus, this is minus, then what will happen? This second branch is for Vi negative, Vi less than 0. Second branch is always open always, like, okay, second branch is always open, and first branch called closes when Vi, magnitude of Vi is greater than equal to 2.7.
1.7.
Okay, and if Vi magnitude is less than 2.7, first branch is also open. Okay, so here also, like up to here 1.7, you get everything open. It is open, this is always open, negative, and after that this will close. Okay, so this is your graph, 1.7 and 2.7. Okay, now you can draw a sine wave for this one.
Sir,
Hmm.
why did you take mod there?
Mod here because the negative values, na, I want to tell the V input is negative. Okay, so you can, if you want, so how can you write? Vi should be, if I negative, so what should I write? Vi should be less than or greater than 2.7.
Minus 2.7.
Less than 2.7 means, now less than means you are mean now 3, 4, 5. Okay, the meaning you should understand. Okay, when I say Vi is less than 2.7 means it is 3, 4, 5, 6, 7. Less than means not 2.5, 2.4. Or what should I write? It should be Vi greater than 2.7. Okay, I can write like this. Just to make you clear what I'm trying to hear. So here it should be less. Here should be greater than minus 2.7. Okay. So obviously Vi is negative. Okay, Vi is always negative here only. But the negative may, what should be the value? What should be the magnitude? That's why I'm writing here. Okay, so that should be clear to you. The logic you should understand, then you can draw, later you can draw. Okay, clear? So this is a clipper. Okay, in this way you can practice many questions on clipper. Okay, so that is given in your material. Okay, now let me talk about the diode resistance. Okay, so DC and AC resistance of diode. Okay, DC and AC resistance of diode. AC resistance of diode. Okay. So if a diode is given, so I know the IV characteristics of diode is given like this. Okay. Now this is by ID. This is the voltage drop across diode, and the current flowing across diode is ID. Okay. At this point, okay. Okay. So if I want to find the resistance at this point, okay. So I need to find what is the current here, what is the voltage here. So each point you have a different resistance. Okay. So DC resistance of diode, DC resistance, okay. DC resistance of diode is given by simply VD by ID. Okay. at particular point P, wherever you want to calculate. Okay, at that point you need to find what is VD and what is ID. Okay, so if I write VD here, okay, so that will give you the DC resistance of the circuit. Okay, now if I want to find the AC resistance, okay, I will talk tomorrow about this one much. Okay, what is AC resistance? But just because some time is left here, so quickly I want to calculate what is how to calculate AC resistance. Okay, now suppose if you're applying AC signal, here you're applying fixed voltage, okay, and you are getting fixed current. Okay, now suppose you're applying a signal which is varying in which is varying with time. Okay, it is increasing, it's varying with time, it is increasing, it is decreasing. Okay, then what will happen? Suppose this is the 5 volt. Okay, now across this 5 volt, if you're applying some 50 volt or 550 millivolt 50 millivolt signal, okay, so what will happen? For if your voltage V5 becomes 5 volt plus 50 millivolt, are you getting my point? Suppose you have a diode here. Okay, this is your diode, and you are applying some DC voltage here, V DC applying. Okay, and the voltage drop across diode is VD. Now top of this DC supply, if you add a small signal, small AC signal, okay, a small AC signal, V like Vm sin omega t, VAC equals to Vm sin omega t. Okay, so say Vm is 50 millivolt, say a small signal, okay, 50 millivolt. Now this is a 5 volt already is there, okay, because of this battery. Okay, now you are applying little bit more voltage. So what will happen? Whenever this is a plus, the pulse is positive, so this pulse will add here. Okay, and this will become 5 volt plus 550 millivolt, and then your operating point will go somewhere here. Similarly, if you apply now, similarly, if this goes negative cycles, if the signals go negative, okay, then the total voltage across will be 5 volt minus 50 millivolts. The voltage across diode decreases. So what will happen? It will come here somewhere here. Okay, so your operating point will shift depending on how much AC voltage you're applying. Okay, so this is your point. Okay, and suppose if I'm applying a wave here. Okay, so what will happen? This operating point will also shift. If it is 0, you're 0. If it is increasing, okay, so if it is increasing, then what will happen? This your ID will also change. Okay, ID will vary from here to here. Okay, ID will take this jump with the applied signal. Okay, and this signal generally, when I say AC resistance, okay, then instead of AC we should write a small signal, small AC signal resistance, small AC signal resistance, small AC signal resistance. I should use the word. Okay, and that how can we calculate? Suppose the diode current ID is given by IS, okay, exponential QV by NKT, okay, -1. Yes or no? It is diode current. It is value of the diode current.
Yes.
Okay. Now, what you can do, you just differentiate this del ID, okay, and say this is a diode voltage or diode. Just differentiate this one, del ID upon del VD. Tell me what's coming. Tell me what's coming. So if I now differentiate this one, this will give me, okay, IS exponential QVD upon NKT. Okay, and if I do this one again, This will give me what? Q upon NKT. Q upon NKT, and this minus 1 will be 0. Okay, and this will become what? This is again your ID. Okay, yes or no? Just 1 minute. If I take, okay, this will be what? ID. This will be your IS exponential will be what? इसकी वैल्यू क्या हो जाएगी बताओ? IS exponential की ID plus IS. This value will be ID plus IS. Yes or no?
Yes, sir.
Very good. Okay. Now delta ID upon delta VD is, now IS is very negligible compared to ID. So I can replace this by ID. I can neglect this IS. Okay. Neglect this one. Okay. And then you have Q upon NKT. Okay. And so I can write this as a NKT by Q. Okay. And this is equal to ID. KT by Q is what? Thermal voltage. What we already seen. KT by Q is thermal voltage. Okay. So ID upon and eta VT. Now, just I will do a little bit more simplification, or not simplification, just now you want, this is delta ID by VLD. Now I want AC resistance. Okay, AC resistance of diode is represented by RD or RE. Okay, and that is equal to delta VD upon delta ID. That is what become eta VT upon ID. So this is your AC resistance of diode. Okay, or small signal resistance. Small signal. Okay, AC resistance. Okay. Now eta value is 1 for ideal diode. Okay, and you know also that VT is 26 millivolt. Yes or no? VT value is what? At room temperature is what? 26 millivolt. So you can write this as a 26 millivolt upon ID. This is the formula for your AC resistance. Okay, for ideal diode, you can take eta equals to 1, and VT value is 26 millivolt, and ID will be also in milliampere. So you can find what is the resistance in the circuit. Okay, DC resistance of the circuit. Now I will talk about this tomorrow. Okay, so I'm stopping here. If any question, please ask.
एक बार सिर्फ आपने जो ग्राफ ड्रॉ किया, मतलब वर्किंग समझ में आया, ग्राफ नहीं क्लियर हुआ, मतलब इनपुट पे आउटपुट।
ग्राफ का मतलब क्या है? आपका वोल्टेज फिक्स है. Is I am superimposing one more signal here on top of this 5 volt. If I'm giving positive voltage, okay, if I'm giving positive voltage, so what will happen? Whatever the current is there, okay, suppose current is here somewhere in the beginning, this is the value, your current is this one. Okay, yes or no? This is the voltage and this is the current level. Now if I'm giving more signal, so my current will increase. Okay, if I'm going again, coming back, my current will come back to same position, 0. If I'm going down, my current will also decrease. That is the meaning of this one. Okay, current will decrease. So this graph will come like this. If going down, this one. So this is change in current due to applying a small signal AC on top of this DC. Okay, on top of the DC, DC, and I'm applying some small signal across this one. So the current is also changing.
सर
अगर
अगर वो DC वोल्टेज ना हो तो भी ये रिजल्ट वैलिड होगा क्या?
That is good question. हाँ, तब भी अलाउ होगा, तब ये रेजिस्टेंस आएगा. ओके, तब ये आप मान लोगे कि ये आपका 0 पे है और क्या. अगर बट इसको कंडक्ट तो कराना पड़ेगा ना, इसको कंडक्ट तो कराना पड़ेगा ना, तो एक मिनिमम वोल्टेज तो होना ही चाहिए. तो हमेशा जब एसी सिग्नल लगाते हैं डायोड में डीसी बायसिंग, एसी रेजिस्टेंस निकालना है तो डीसी बायसिंग होना जरूरी है.
ओके
कल करेंगे क्वेश्चन इसके, बताऊंगा जैसे क्वेश्चन करेंगे. तो बेसिकली व्हाट आई एम ट्राइंग टू से, DC, how to deal diode with this DC signal, I know. Okay, but if I superimpose one AC signal across with this diode, then how diode will work, how to tackle that diode in the circuit. Okay, जब AC DC दोनों है, and AC you cannot apply like a very big signal. Okay, you have to apply only a small signal. Okay, so diode will make either this signal, this is a conducting, and across this conducting state you have to apply a small signal, AC amplitude, and then we will deal this. We have to find a current in the circuit. Okay, how to tackle this diode in the circuit, that we'll tomorrow discuss. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.